In this video, we'll be covering functions that are considered even or odd. Now, even functions specifically have the property such that if you replace all of your x's in the function, you obtain back the original function. So, for instance, the function f of x equals x squared is considered an even function because when you replace your x inside the function with negative x, you obtain back the original function, f of x. Again, other functions that might have this property revolve around the concept that every power of each term happens to be an even power. So I might have something along this line, and this is still considered even. Again, not because of the powers, but because the property is when I replace all my x's with negative x, I obtain that the simplified version of this function right here is the original function. So this is for even functions. Odd functions, on the other hand, have that if you replace your x with a negative x, you actually obtain back a negative of the original function. So, for an example, f of x equaling to x cubed, if I were to replace my x in this formula with a negative x, I would obtain negative x cubed, which will simplify down to be negative x times negative x times negative x, which would be negative x cubed. Again, notice the difference between the orientation of these particular details is that this is negative is on the inside of something cubed, and this negative is on the outside, with that x being cubed. This, you'll notice, is a negative of the original function and therefore satisfies that property of being odd. So now we have two very specific properties. We have an even function and we have an odd function. Now, if we were to attempt to manipulate a function so that it has both even and odd terms, for instance, 3x to the fifth plus 4x squared minus 2x plus 1, this function would not be considered even, nor would it be considered odd. Because if I were to attempt to replace all of my x's in this function with a negative x, again, very carefully making sure that I put parentheses around all of the terms that I'm plugging in, then you'll notice that the sign will change on certain terms but not on others. So for instance, right here, a negative x to the power of 5 will change that sign because an odd power or an odd multiple of a negative number will spit back a negative, whereas in here, this will not change in sign because a negative x squared is just a positive x squared. Then this sign here will change, and that will remain the same. You'll notice right here that this is not equal to the original function. Secondly, if you were to attempt to factor out a negative 1, again, as you're trying to prove that this thing is an even or an odd function, you'll notice that this is the negative one that we're looking for in the formula up here. But this is not the original function. Notice it's a positive term, then a negative term, but this is positive, negative, where this is 3x to the fifth, but positive 4x squared, negative 4x squared. So this is not equal to a negative of the original function, and therefore, this is neither even nor odd. So again, we have possibilities of even functions. You have the possibility of odd functions. Now, the major detail that comes from this is the concept of symmetry. So, if somewhere in a problem you are asked to determine the symmetry using even or odd, what you can identify is, first off, you'll notice that this x squared function back up here, if I were to try and sketch this, it would look something along the lines of this. You'll notice that this function here clearly has an axis of symmetry going down the y-axis. So we would call that this function having y-axis symmetry. Something we can also conclude is that all even functions will imply that we have y-axis symmetry. On an odd function, however, if I were to go ahead and sketch this curve down here, this curve looks something along the lines of this, and you'll notice that I can rotate this curve around, creating myself, again, an origin symmetry problem. So every odd function we have will, in turn, be an origin symmetry graph. So, with these two details understood, down here, if I'm determining the symmetry using even or odd, and I've given you the function f of x is equal to x cubed plus 3x, then what you can identify is that, first off, f of negative x is equal to negative x in parentheses cubed plus 3 times negative x in parentheses, which is negative x cubed minus 3x, which is equal to negative 1 times x cubed plus 3x. And this is very clearly, again, in conclusion, equal to a negative 1 times the f of x function that we originally had. This implies that this function is odd, and odd will imply that this function has origin symmetry. Now, the final note to make is the helpful understanding of how to remember which is which. Well, first off, let us start with the types of symmetry you may find. You may find y-axis symmetry. You may find origin symmetry. One that would make sense because you have y-axis, well, why don't we have x-axis symmetry? Next, in terms of other symmetries we may find, those will come up, but they will not be more important than these three. So when asked to find symmetry using even and odd, it will have to be looking at these three details. Now you'll notice right here, y-axis symmetry, we already said, was an even function. Secondly, origin function is going to be considered an odd. An origin symmetry considers that the function is odd. And then the last piece is, well, what about x-axis symmetry? Well, x-axis symmetry would cause us to not have a function because it doesn't pass the vertical line test. So over here, it would not be a function. Okay, and the other detail is that we might not have any symmetry, which could be neither even nor odd. So the way to remember is notice that this starts with an O and this starts with an O. So odd and origin go hand in hand. That leaves me to say, well, x-axis symmetry doesn't ever make a function, so those two have to be grouped together. And then finally, y-axis then is left to be an even function. So those are your three little reminders to not forget how we can correspond. And again, the biggest detail is the fact that f of negative x has to be equal to f of x for an even function, and f of negative x has to equal to negative f of x for an odd function.